Good day, viewers. I welcome you to today's class on numerical integration. We shall be looking at numerical integration today, how to use various methods of integration to carry out the integration of a function when the function is not known explicitly. Now, once again, my name is Dr. Chris. I welcome you to today's class on numerical analysis. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. Click on the notification button and share my videos on your social media platform. Today we shall be looking at numerical integration, where we shall be using these three methods: the trapezoidal rule, the Simpson's 1/3 rule, and the Boole's rule to carry out numerical integration. Now, in a scenario where you are given a set of data as x0, y0, comma, x1, y1, comma, x2, comma, y2, down to xn, comma, yn. These data sets or data points are of the function y is equal to f of x, comma, f of x is not known explicitly. So when f of x is not known explicitly, we can carry out numerical integration of the form I equals, we can carry out the definite integral of the form from b to a y dx, or we can simply write it as from xn to x0 y dx. So this is what we try to achieve when a data set is given with data points and the function itself is not known explicitly. It is still very much possible to carry out numerical integration. Very much possible to carry out numerical integration. So that this is what we shall be looking at today. Even if the function is given without data points, we can bring out the data points and still carry out our numerical integration. In a scenario where the data points are given and the function is not known explicitly, we can still carry out our numerical integration. So please be patient with me. Try as much as possible to watch this video to the end. So we shall be using these three rules today: the trapezoidal rule, the Simpson's 1/3 rule, and the Boole's rule to solve a problem on integration. For instance, if we are given a function as this, integral 1 to 0 3x squared plus x dx. This is a problem on integration. It's a definite integral. Now, if I want to carry out this integration, I will first of all use the conventional method that we all know. The conventional method states that if I have integral of the form integral x dx is simply having integral is simply x raised to power 2 all over 2, or okay, let me take it this form. If I have integral x raised to power n dx is simply x raised to power n plus 1 all over n plus 1 plus c. C there is the integration constant. So this is the general conventional method for carrying out integration. So this one is generally. Then of course when it has upper bound and lower bound, then it is definite. We have two types of integral. We have the definite integral and the indefinite integral. So we are using the numerical methods to solve definite integral, the one with the upper bound and the lower bound. So this is the general way for carrying out integration conventionally. Now if it is definite, it means that the integration constant c will vanish. So if I want to carry out this integration, I'm going to have it as, if I integrate this will be 3x raised to the power 3 all over 3 plus x squared over 2. Then the upper bound is 1, the lower bound is 1. So of course this 3 here will cancel, will go out. So I will have x raised to the power 3 plus x squared over 2. Then the upper bound and the lower bound will still remain. The integration constant has already cancelled out anytime you are carrying out definite integral. So now this will now become integral 1 to 0 3x squared plus x. The x will now simply become, you open the bigger bracket, the upper bound will take the first value to be 1 raised to the power 3 plus 1 squared all over 2. You put the bracket minus that of the lower bound, 0 raised to the power 3 plus 0 squared all over 2. So this will be equal to 1 raised to the power 3 is 1 plus 1 raised to the power 2 is 1 plus 1 all over 2. Of course this other part will be 0. So this will be equal to 1.5. In numerical integration, anytime we are carrying out numerical analysis, it is advisable you put your results in decimals, and again you take as much decimal places as possible so that you can prevent or reduce what we call the inherent error. So using the conventional method to solve this problem, we have seen that the answer is 1.5. Now we are going ahead to use the trapezoidal rule, the Simpson's 1/3 rule, and also the Boole's rule to solve this same problem. Then we can now go ahead to calculate our truncation error. We'll now go ahead to calculate our truncation error. So you note our y is f of x, is a function of x. So this y here is a function of x and is integrated with respect to x. So for this particular problem, using our conventional method, the answer is 1.5. Now we want to go ahead to use the trapezoidal rule first to solve it. The trapezoidal rule, the Simpson's rule, these rules were gotten from the Newton's forward difference interpolation formula by setting n to be equal to 1 for the trapezoidal. For the Simpson 1/3 rule, setting n equal to 2. Then for the Simpson 3/8 rule, and so on and so forth. The Boole's rule, you set n equal to 4. The Weddell's rule, you set n equals to 6. So today we are looking at part 1 of this video. So we are looking at numerical integration part 1. So we will not be able to cover all the methods today. So that's why we are considering 3 methods first: the trapezoidal rule, the Simpson's 1/3 rule, the Boole's rule. So in our part 2 of it, we shall be considering the Weddell's rule and the Simpson's 3/8 rule, and so on and so forth. So permit me to clean the board as we go ahead to start using each of these numerical methods for integration. So take note of this problem. Our conventional method has given us a true solution, and that true solution is 1.5. So we'll be calling for it when we want to calculate our truncation error. So now let's write out the trapezoidal rule. The trapezoidal rule is given like this: integral xn to x naught y dx is equal to h all over 2. Our h again is the step length for x, h over 2 into y naught plus 2 into y1 plus y2 plus y3 plus yn minus 1, that is the second to the last value of y, then plus yn. So this is the trapezoidal rule. This formula was derived from the Newton's forward difference interpolation formula, setting n to be equal to 1. When that formula was integrated and n was set to 1, then we arrived at this trapezoidal rule. I told you when we are looking at numerical integration, we shall not be doing much on derivation of formulae. Instead, we shall be doing more on application. So remember the problem we are told we just solved. For that particular problem, our y is equal to 3x squared plus x. 3x squared plus x. And again, the problem is integrate 1 to 0 3x squared plus x dx. So here we are setting our h to be equal to 0.2. So h will be given. So h will definitely help us to spread the value of x. Now let us create a table of x and y. So we have our x, we have our y. Now look at it. X takes value between 0 and 1. So x will be starting from 0, and of course it will be increasing with h. So the next one will be 0.2, the next one will be 0.4, the next one will be 0.6, the next one will be 0.8, the next one will be 1.0. You stop there. So you stop, you start from 0, and x will increase with h till you get to the upper boundary. You start from the lower boundary till you get to the upper boundary. So you are not permitted to go below 0 for x, you are not permitted to go above 1 for x. Now, using this, we can get our y. So when x is 0, 0 squared is 0 times 3, 0 plus 0 is 0. Now, when our x is 0.2, 0.2 squared times 3 plus 0.2, you are going to get 0.32. 0.32. Then when x is 0.4, 0.4 squared times 3 plus 0.4, you are going to have 0.88. 0.88. Now when x is 0.6, it's good we partition it so that we have it differently. When x is 0.6, 0.6 squared multiplied by 3 plus 0.6 is 1.68. 1.68. Then you come here again. When x is 0.8, 0.8 squared multiplied by 3 plus 0.8 is 2.72. 2.72. And lastly, when x is 1, 1 raised to power 2 is 1 times 3 is 3, 3 plus 1 is 4. So we have created a table having values of x, and y. So this is what we have succeeded in building. So we have gotten a value or a table of values for x and y. So this is how we have created the table. H is given, and H will help you to spread X from the lower boundary to the upper boundary. And of course, you see the problem is y dx, so the y itself is a function of x, and our y here is 3x squared plus x. So we have been able to create this table. Then the next thing now is to carry out our integration using the Boole's using the trapezoidal rule. Now using the trapezoidal rule, integral 1 to 0 3x squared plus x dx will now be equal to, look at the way this formula is applied. What is our h? Our h is 0.2. So you have 0.2 all over 2. Then you open your bracket. Now listen. This thing is very easy to understand. If you look at it here, it is running from x0 to xn, and it's also running from y0 to yn. So I will permit me to label it. Let me call it, this is my y0, this is my y1, this is my y2, this is my y3, this is my y4. The last one, you reserve it as your yn. If you label it this way, you will be able to get it cheaply. You will be able to understand it better. So you start from y0 to yn. Now this is how we are going to apply it. You can see that the y0 is on its own here, and our y0 is 0. So you have 0 plus, we are following this formula, 2 into bracket open. Now what are the values inside the bracket? From y1 down to the second to the last y. You can see that your yn is also reserved. It's not part of the bracket. So you put everything from y1 to the second to the last y. So you are putting them in. You start by putting 0.32 plus the next one 0.88 plus the next one 1.68 plus the next one 2.72. Then you close the bracket. That is what we have done. Then yn is put at the last, then plus your yn, which is 4, then you cover the entire bracket. That is how it is done. So if you come here right away, you now have 0. You now have, when you have all this, you are going to have your 0 over 2 divided by 2. You are going to have 0.1 into, when you add everything up, you are going to have this is 0 plus, when you add all this, you have 2 into 5.6, then plus 4, then you cover the bracket. So 2 into 5.6, this will now be equal to 0.1 into 2 into 5.6 is 11.2 plus 4. You have 11.2 plus 4. So this will now be equal to 15.2. That is 0.1 into 15.2. And that will now give us 1.52. You see that? So using the trapezoidal rule to solve this problem, you will get what we call, we have an answer that is 1.52. The conventional method we used, we got 1.5 on the dot. So it is very easy now to calculate our truncation error. Our truncation error will now be equal to the true solution minus the numerical solution. Our true solution is 1.5, remember, using the conventional method. Then our numerical result or solution using the trapezoidal rule is 1.52. So our answer will now be equal to minus 0.02. That will now be our truncation error. So you can say that the trapezoidal rule has produced a result that is close or very close to the result from the conventional method. The result from the conventional method is the true solution is 1.5. We solved it earlier. While the result got in using the trapezoidal rule is 1.52. So this is how to apply the trapezoidal rule. Now permit me to go to the next method, which is the Simpson's 1/3 rule. I will leave this table because we are still going to use this table. Simpson's 1/3 rule. We are looking at Simpson's 1/3 rule. Now, Simpson's 1/3 rule. First of all, I will write out the formula. So the Simpson's 1/3 rule is given as integral xn to x naught y dx is equal to h/3 into y naught plus 4 into y1 plus y3 plus yn minus 1 plus 2 into y2 plus y4 plus yn minus 2, then plus yn, then the bracket is closed. Remember again, our problem is integral 1 to 0 3x squared plus x dx. Then if this is y, that means what we have in the bracket here is y. Our y will now be equal to 3x squared plus x. Of course, h is given as 0.2. So we were able to create this table out. The table will be very useful to us. So now we want to see how we can apply this Simpson's 1/3 rule. Now let's see how it can be applied. Now solving this, integral 1 to 0 3x squared plus x dx will now be equal to, of course, our h is 0.2/3. Then of course our y naught is 0 plus, this is where you need to listen attentively so that you can get this message. Now look at it, 4 into y1 y3, that means the y's in the odd positions, y1 y3 y5 y7 y9 and so on and so forth. You will take them and add them. Of course, the last y is reserved, the yn is always reserved. Then look at this one, 2 multiplying the y's in the even position, 2 4 6 8, like that till you get to the third to the last value of y. So now what are the y, what is our y1? Look at our y1 and our y3. So this will be 4 into 0.32 plus, look at y1, look at y3. y3 is 1.68. You cover it, then plus, those are the only two values. You, of course, you cannot take this one as part of it because the yn is reserved, it's not part of the bracket. Then this one will be plus 2 into, this one is y2 y4. Look at our y2. Our y2 is 0.88 plus our y4 is 2.72. You cover the bracket. Of course, you cannot take any other. Then the last y, which is yn, is also reserved, plus the yn, which is now 4, like you have it here. Then you cover the major bracket. That is how it is done. That is how it is done. So you will now come and have, this will be equal to 0.2/3 into, of course, 0 multiplying anything remains, the thing remains itself. So you are going to have 4 into 0.32 plus 1.68, that will be 2 in value. Then plus 2 into 0.88 plus 2.72, that will give us 3.6. So you have 3.6. So this will be equal, you cover the bracket. So this will be equal to 0.2 over 3 into 4 times 2 is 8. Of course, there is a 4 there, plus 4, there is a 4 there. So adding all this, you are going to have 0.2 over 3 into, of course, 4 times 2 is 8. Then 2 times 3.6 is 7.2. So you are going to have 8 plus 7.2 plus 4. That's what you are going to have. So when you carry out that multiplication, you have 0.2 over 3 into, when you add that, you have 19.2 into 19.2. Somebody may ask, why did I not carry out this division? If you say 0.2 over 3, you are going to get 0.066666666. The decimal is non-terminal. You are going to have 0.0666. So what for you to reduce or prevent much of inherent error, the best thing you do is what I have done. You will now say 0.2 divided by 3 using your calculator. You say 0.2 divided by 3, it will give you the answer. If you're calculating 8 can take up to 10 decimal places, 40 decimal places, you leave it like that. Then you now say times 19.2. Instead of you reducing it here, it's possible for me to write 0.06666 up to maybe 5 decimal places. I will commit what we call inherent error, and it will affect the answer. So in numerical analysis, you try as much as possible to avoid inherent error or reduce it as much as possible. Inherent errors are rounding up errors. When you round up a particular number, you have cut off part of the solution, and that will make the numerical solution to be different from the true solution. So when you carry out this, you are going to have 1.28. So solving using the Boole, the Simpson's 1 over 3 rule, you have 1.28. Again, our truncation error is equal to the true solution minus the numerical solution. Of course, remember our true solution is 1.5, and our numerical solution here using the Simpson's 1 over 3 rule is 1.28. So this leaves our truncation error to be equal to 0.22. So if you want to make a decision based on the two methods we have used to solve this problem, you will see that the trapezoidal rule produced a better result because it has a lesser error. The error from the trapezoidal rule is minus 0.02. The error from the Simpson's 1 over 3 rule is now 0.22, which is higher than that from the trapezoidal rule. So this is how you use the trapezoidal rule to the trapezoidal rule and the Simpson's 1 over 3 rule to solve this problem. Note, if f of x is not known explicitly and the table of values is given, of course you can apply the formula. And when h is given, you can also, even if f of s is given explicitly and h is given, you can create the table of values and use the numerical formulae, the numerical integration formulae that you have chosen, whether the Boole's rule, whether the Weddel's rule, or even the trapezoidal or Simpson's rule. So this is the part 1 of it. We shall be looking at part 2 after this video is short. Now we want to quickly look at the Boole's rule. Take note, we have solved this problem using the trapezoidal rule and the Simpson's rule. Now let us look at the Boole's rule. We may not need this table for the Boole's rule. I will tell you why. Because the Boole's rule, n is equal to 4, it has its own formula that it's using, and its own, there is a different way of applying the formula, because when you are using the Boole's rule, you will not be given h. You have to solve for h. You have to solve for h yourself. You have to solve for h. You have to solve for h. So the Boole's rule is given as integral xn to x naught y dx is equal to 2h over 45. It was derived using the Newton's forward difference interpolation formula, setting n to be equal to 4. All brackets open. You have your 7 y naught plus 32 y1 plus 12 y2 plus 32 y3 plus 7 y4. That is the Boole's rule. It was derived setting n is equal to 4. Now you will know that for you to get your h, there's a formula you use to get your h. H will now be equal to b minus a all over n. For the Boole's rule, n is equal to 4. N is equal to 4. And now remember the problem that we have been given. This is the problem we have been given. We have to integrate integral 1 to 0 3x squared plus x dx. When the table of values are given, now you have to get your h from this. The upper bound is the b, the lower bound is a. So our h will be equal to 1 minus 0, which is b is the upper bound, a is the lower bound, all over n. N is 4. So this will be 1 all over 4. So this implies that our h will be equal to 0.25. So this is what we are now going to use to create our table. So of x and y. So you have your x, you have your y. So note x is taking values from 0 to 1. So you start from 0. The next one, of course, x is increasing with h, which is 0.25. The next one will be 0.25. The next one will be 0.50. The next one will be 0.75. The next one will be 1.00, as the case may be. Now, when x is 0, of course, what will become of our y? Our y will be equal to 3x squared plus x. When x is 0, 0 squared times 3 plus 0 is 0. When our x is 0.25, 0.25 squared times 3 plus x, that will give us 0.4375. 0.4375. Then when x is 0.5, you have 0.5 squared times 3 plus 0.5, that will be 1.25. When x is 0.75, you have 0.75 squared times 3 plus 0.75, that will be 2.4375. 2.4375. And again, when x is 1, 1 squared times 3 will be 3 plus 1, and that will be what? 4. It's as simple as that. Now that you have created this table, I will always tell you to do your numbering, do it neatly, This one will be your y0, write it neatly. This will be your y1 for, so that when you are tracing it, it will be easier. This will be your y2, this will be your y3. Now you are permitted to write this one as your y4 because the Boole's rule stops at y4. It stops at y4. Here your n is equal to 4. It stops at y4. So now we can now use the Boole's rule to carry out this integration. Of course, we know the conventional method gives us 1.5. So integral 1 to 0 3x squared plus x dx using the Boole's rule will be 2 into what is our age, 0.25 all over 45. Then now 7 into our, what is our y0? Our y0 is 0 plus 32 into what is our y1? Our y1 is 0.4375. Then plus the next one is 12 into what is our y2? Our y2 is 1.25. Then plus the next one is 32 into our y3 is 2.4375. Then of course plus 7 into y4. 7 into our y4 is 4. Then you cover the bracket. So carrying this out, 2 times 0.25 will give us 0.5 over 45. 0.5 over 45 into, when you carry out all those values, you are going to have 7 times 0 is 0 plus 32 into that value will give you 14 plus 12 into 1.25 will give you 15 plus 32 into 2.4375 will give you 78 plus 7 into 4 will give you 28. So this will now be equal to, it will now be equal to 0.5 over 45 into 135 into 135. Now, do you know why I left it at 0.5 over 45? If I have that value, I'm going to have a very long decimal. Again, I will commit inherent error. So that's why I reserved 2 multiplying 0.25 will give me 0.5. If I divide 0.5 by 45, I will have a very long decimal, a non-terminal decimal. So I will be forced to commit an inherent error. So the best way to do it, you just press your 0.5 divided by your 45, then the answer, then you multiply it by 135. You will simply have 1.5 on the dot. So using the Boole's rule, we got exactly 1.5. So the Boole's rule has given us exactly 1.5. Exactly 1.5, which is not different from the conventional method. So our truncation error will be equal to the true solution minus the numerical solution is equal to 1.5 minus 1.5 is equal to 0. So the Boole's rule is error-free. The Boole's rule is error-free for this particular problem. It has equal results with the conventional method, 1.5. So we have used these 3 methods successfully to solve a particular problem. So for this problem, the Boole's rule is the best, followed by the trapezoidal rule. The Boole's rule gave us zero error, that means it's error free. The trapezoidal rule gave us minus 0.02, while the Simpson's 1/3 rule gave us 0.22. So these three methods have been used to solve this problem numerically, to integrate this problem numerically, and that is the end of part 1. We shall be looking at part 2, which part 2 we have to do with the Weddel's rule, the Simpson's 3/8 rule. We shall be using them to solve more problems in part 2 of numerical integration. So please watch out for part 2 and watch this video carefully to the end, so that you will have a better understanding of what numerical integration is. Once again, my name is Dr. Chris Esekaibe. I hold a bachelor's degree in statistics and a master's degree in mathematics and a master's degree and a doctorate degree in mathematics. I hold a bachelor's degree in statistics with a very sound grade, a master's degree in mathematics, applied mathematics, and a PhD in applied mathematics. My area of specialization is numerical analysis. I also deal on data analysis and modeling, statistical analysis, and scientific computing. You can contact me with your problems in mathematics and statistics, especially with your research work, for consultation. You can drop a message in the comment section. If you want me to teach any topic that is challenging to you, please drop it on the comment section. I will do that and upload the video for you. God bless you. Share my video in your social media platform. Subscribe to my channel. I'll be coming up with a part 2 of numerical integration in a few days from now. Please watch my videos to the end, like my videos, share them, and as you do, God will bless you. Enjoy the rest of the day. Bye. See you in the next class.